Now let us discuss case 2. Case 2 is that insertion happens to the right of the node P and then B. Okay, it is just opposite to the case 1 that we have discussed right now. Note down a new node. This is a new node. Okay, a new node is inserted to the right side of the node P and then B. So in order to make this tree balance, we have to rotate in the left direction. In case 1, we have rotated in the right direction. Now we have to rotate in the left direction. Now you see, after applying single in the sense one time, single left rotation, the tree will become like this. Okay, you rotate this. So B will go at the top, P will come to the left of this. There is no change in the BR. Why? Because all BR is greater than. BR means right subtree of the node B. There is no change in BR, and also a new node is come in that right position. Similarly, there is no change in the PL. Okay, because PL is the left subtree, so it should come to the PL, left of PL. Where does this BL goes? Note down, BL is lesser than B but greater than P. Okay, so lesser than B, greater than P. So we have safely insert all the left subtree of B in this position. Now you see, after applying the single left rotation, the tree maintains the balance. Okay, so this is the solution whenever a new node insertion happens to the right node of the P and then B. In that situations, we have to apply the left rotation. Now let us take the example in order to understand this better for case 2. Now let us take the example to understand case 2. Now this is the binary search tree, or this is an AVL tree which satisfies the property binary search tree as well as the balance factor. Now let us calculate the balance factor for each node. For all the leaf node, the balance factor is 0, and for this also the balance factor is 0. For this is -1, for this is 0, and for this is -1. Okay, since the balance factor for every node is either 0, this is bigger, 0, -1 or 1, we can say this tree is an AVL tree. Okay, now let us take one node insertion. Let's say I want to insert a node whose value is 12. Okay, now first procedure is that we have to figure out where the 12 has to go. Okay, now let us take this node 12. Since 12 is greater than 7, we reach to the right side of that, and 12 is greater than 9, we reach to 11. 12 is greater than 11, we reach to 13. And then since 12 is lesser than 13, we can insert a new node in this position. Okay, this is a new node. Let me call that the new node is this 12, whose value is 12. Now let us calculate the balance factor after inserting a new node which is 12. Okay, previously let us calculate the balance factor for this is 0. Now let us calculate, this is a leaf node, this is 0. Now the balance factor for this node is 1. Here there is no change. Here there will be a change. Note down, wherever in which path we have inserted a new node, only that path balance factor only changes happen. Okay, and then this balance factor is -1 for this node. Now the balance factor -2, and for this the balance factor is -2. Now because the insertion was happened in this path, only in this path all the balance factor got a new value. Now we have to figure out what is the node P and then B. Once we fix this P and then B correctly, then we have to simply rotate. Okay. Now as I said that the same procedure, from the bottom you look at the node on the path. Okay. The node which violating the balance factor. Now it is satisfied. Here also it is satisfied. Balance factor is satisfied for this node, but here is the node the balance factor is violating. Now this is you fix this node is P actually. Okay. Once we figure out the P, the node B can be in the right side of that P, which is B. Now you see this, the insertion happens, where that insertion happens in case 2, right of the node P and then B. So this is right and then right side of the node. Okay. So it could be insertion happens to the left of 13 or right of 13, but the insertion happens to the right of node P and then B. Fine. Now we have to apply the rotation. What rotation? We have to apply left rotation once. Where we should apply? We have to apply at the node P. So you apply or rotate in the left direction. Okay. Let's see, after apply the left rotation, where does that P and then B will go. So you see this figure, if we apply this, B will come to the root. So now 11 will come here. Okay. So node 11 will come here. So what is this? This is B. Now as soon as you see, you write down the value B. What is P? P is 9. Okay, this is P. Okay, and what is PL? PL is 8. No change in PL. Similarly, no change in BR. So what is BR? 13. 13 left is 12. This is the new node that we have inserted. Now what is BL? The BL is this 10. So now where it goes? BL will goes to the P. So now this is P. Now we can move BL. Left of B is 10. 10 can insert in the right direction. So this satisfies the property, and there is no other changes on the path, and the remaining node you could connect as such. Now here there is no change. Now this is at level, what level? 5 is at level 1. So we maintain the same thing. This is level 1. And then this also at level 1. 5. Left of 5 is 4. Right of 5 is 6. Okay. And then the node, the root node for this is 7. Fine. Now you calculate the balance factor for this node 0, 0, 0, 0, 0, 0, and then for this B is also 0, and this is -1. Okay. Now every node in this AVL tree satisfies the property. Now this tree is an AVL tree, or it is self-balanced. Okay. Now let us discuss case 3.